I think I have the slide now. Where is it again? Desktop screen. I am sorry. I think I don't know how to use this. I'm used to Microsoft. Okay. Thank you. And sorry for that itch. Once again, I want to thank my alma mater, if I can put it that way, at least Lagos State University, Ojo campus was where I started in full flesh, although I'd had another university experience at University of Maiduguri. But most of my teaching in Nigeria was from Lagos State University. And I'm glad that I can plow back into that institution. Thank you for investing so much trust in me to think that I will be able to take this particular topic. And I want to challenge everyone seated or listening to this topic or to this discussion. I'm sure by the time you finish, you will begin to see research in a different way. So we want to look at how we will be shaping the chemistry of natural product for sustainable products.
It's in the
For
departmental
sustainable product in combating current and future health challenges.
I don't know why the.
My outline, I will just try and discuss what natural products are, the current health challenges that we have, and then the call for this conference or for my plenary talk, and then I will try and conclude as much as possible. So what are natural resources? At times when we talk about what natural resources are, the first thing that goes into the mind of people is that it is coal or it is crude oil. Those are natural resources. We don't think of other things. There was once a time I conducted an interview in Nigeria about what natural resources are because I was told to talk on natural resources. And I went to University of Lagos. Among the first 20 students that I picked up, I was surprised that all of them just started mentioning crude oil, petroleum, crude oil, petroleum. So they don't really go beyond that because that is what we are being made to believe that natural resources are. But natural resources are material or substances occurring in nature which can be exploited for economical gain. So you don't blame them so much because that natural resource, which is the crude petroleum, is what has been televised all along and has brought economic gain to the country. But it goes beyond that. So you find that natural resources, when you are looking at natural resources, you are looking at things around you that comes naturally, that is given to us by nature. And also we are looking at air, we are looking at water, soil, trees, forest. Trees is different from forest, mind you. Trees, forest, we are looking at mineral resources, we are looking at natural gases, we are looking at petroleum, coal, and animals. So you find out that natural resources are the basis of all human health, and without it, many of us will be dead. If we don't have natural resources, we'll be dead because it's either, you will find out later in my next slide why that will be. So natural resources is not only limited to mineral deposits. Now, if we have to look at natural resources, we have two types of natural resources. We have the renewable and non-renewable natural resources. For the renewable, you'll find that we need the renewable natural resources for our survival. If we don't have that, we won't survive. Like I said, we'll be dead. If we don't have renewable natural resources, we won't have food on our table. We won't have air to breathe. There will be no sunshine, the plants will not grow. We won't have carbon dioxide being taken away. So we need this natural, renewable resources. For the non-natural renewable resources, we just need it to satisfy our needs and our wants, you know, living an expensive life or having amenities, the road, a good country and all that. When the money is managed very well, it will satisfy our desire. So you find out that we have non-renewable and renewable natural resources. And those are the classes of natural, non-renewable and renewable natural resources. Now you find out that the problem that we have, and which has translated into the university and has somehow shaped us as a country, is because for so long we have focused on non-renewable natural resources. And a nation that focuses only on non-renewable natural resources is not a wealthy nation. And that is why we keep on screaming and shouting at the state in which our country are. I hope that by the end of this talk, we will begin to look into the type of research we do, such that we'll be able to create jobs, to create wealth, you know, within the science community, and this will translate into our communities. Now, in terms of current health challenges, the health challenges in the whole world can be broadly divided into two, in which we have the communicable diseases and the non-communicable diseases. But I know that some of us, we just look at the communicable diseases because that is what is around. That is the COVID-19. So I've decided to use the communicable disease as COVID-19 as the example for communicable disease, while hypertension for the non-communicable disease. So let's quickly look at that, because a knowledge of this will help us to now begin to shape our researches in chemistry to address these diseases. Now, from communicable diseases, we find out that these are infectious diseases, you know, that is easily transmitted from one person to another. So it comes in through contact. When one is infected with a bacteria or have sexual intercourse or by oral transmission, you can easily have this communicable diseases. Another one is that by touching a contaminated table or contaminated object, you can easily pick up also these communicable diseases. And then another thing which we don't look at is that mosquito, for example, when you have a bite from insects or animals, you know, those are communicable diseases. That's why malaria is part of a communicable disease, you know. The malaria picks it and they transmit that particular pathogen around people. When you find out that through travel, some bacteria and some diseases are easily transferred. For non-communicable disease, it's a bit different. It's not transferable. It dwells with the person that has that particular disease. But the problem is that particular non-communicable disease lasts very long, and it usually leads to death. So at times it is called the chronic disease, you know, and it's a combination of lifestyle, genetics, the physiology, kind of way the body is made, and then environmental factors. These are things that actually lead to this non-communicable disease. And we have above 50 of them. You know, at times we only look at obesity, diabetes, hypertension to be non-communicable disease, but that is none. Of recent, depression is going on a high rate in Nigeria, and people are committing suicide. That is non-communicable disease. Depression is one of it. And you see, the earlier we begin to look at which aspect of this non-communicable disease or communicable disease that I want to address, then you'll see that our chemistry, our researches in chemistry will begin to make meaning to our society. So I've just listed a little of them. Sleep disorder, for example. If you come across someone with a sleep disorder, then you know that that is a disease. So what is the call? The call is that we should start thinking of how to shape chemistry, the chemistry of natural resources, the things that God has given to us naturally, for us to have a sustainable product so that we are able to fight the current and future global challenges that will come or that is currently facing us. But it is very difficult for us to face that challenge or to yield to that call if we don't identify what the problem is. And the problem is that we are doing research. I know when I was in Nigeria, I was doing research, and I know I've read articles, brilliant articles from colleagues from Nigeria. We are doing research that we cannot argue about. There's research going on, and the research has translated into reasonable products. We carry out experiments and we do it, but then you can see that we have a lot of product on the shelf in terms of papers. We've written so much papers, we've written books, we have books, we have articles, we have theses that students have worked on, but they are all seated on this shelf. But then the essence of a research is that we should be able to translate our research, our laboratory work, into papers and into the community. But this is not the story. Hence, this is where the problem is. How do we take from the chemistry lab into articles or into paper publication, into student productions, graduates, and then we make sure that we also translate this into the society. So half of the research, or most, let me say 90% of the research in chemistry end up here. It ends up in on the shelf, and it's not being translated into useful end. So our community, our sick people, and so the infection is growing on, the depression is going, and we keep on saying, oh no, it's natural. What's happening to that person? Kilon low. Why is he thinking? Why do you want to kill yourself? And you think it's natural. It's not, it's a disease, and it needs to be addressed. I think I am frozen. Okay. So I looked at chemistry, and chemistry has different aspects. We have the organic, we have the inorganic, the analytical and all that. But permit me to go into my own comfort zone where I can really speak about shaping chemistry. And I will be using natural products to explain how we can really shape the natural resources that we have so that we can easily attack or manage our health problems. So when we look at natural products, you find that our natural products are chemical compounds or substances found in nature, which has been given to us by God. But they have unique chemical structures, and we can easily modify or semi-synthesize this into various compounds, and this will result into diversity of biological activity and yield different types of drugs for us. So you find that natural products have become one of the most important resources in the world for developing new lead compounds or drug templates. So you find that from natural products, anti-cancer, anti-hypertensive, name it. A lot of drugs have been formulated from natural product research. Now, let me take a little bit to describe coronavirus, and or let me say non-communicable diseases. And I've really picked coronavirus because it is the thing, it is the in thing, and that we are seeing it as being what is the disease now. But you find out that coronavirus is not new. Coronavirus is not new. This is the third type coming up. Coronavirus has been in existence since 1960. 2 strains have been identified, one in 2003 and another one in 2012, and then the third one came up in 2019. But it's the one that came up in 2019 is the speed at which it engulfed the world made it to become pandemic, and that is why everybody thinks that it is the only in thing. But coronavirus has been on since 1960. So we find out that for the COVID-19, which is the coronavirus 2019, is actually caused by, it's a human strain coronavirus, and it affects the respiratory organs, And then you find out that, sorry, I'm trying to be fast because I'm told I have 15 minutes. And it's believed that it originated from bats, from bats. And because a genomic study was carried out, and they found out that it has 96.2% identity with that found in bats. Now the coronavirus is novel. It has made name, compared to the one compared to the SARS-CoV-1, or the one that was identified in 2012. And it's becoming the focal point. But the good thing is that, like yesterday, Pfizer in UK has been able to bring up a vaccine, and which is now in the market, So that is the good news about it. And I would speak a little bit about it because it's interesting what is in the virus, it's part of it. Now, I want to look at the success story as it relates to coronavirus in terms of natural product, so that we begin to look at what we do as a researcher, when we are bringing up topics or when we want to give students a project topic. Let us begin to shape our research around our community, around the cry, around the societal need of the country. Now, I want us to look at this particular compound, which is called caryolactone. It was first discovered to be an anti-cancer and antibacterial drug, and it was isolated from bacteria, and that is the structure of that particular compound that was isolated from bacteria. Already, if you are a smart scientist, you will understand where I'm going from or where I'm coming from. You can see that is a microbiologist working with a bacteria, and a chemist is coming in. So why am I so interested in this particular compound? The interest came in when it was discovered that this particular compound has the ability, it has the MTHFR1 inhibitor. And what does that mean? It means that it has a broad spectrum, for viruses in bats and in human beings. Don't forget, it has been on the market as an anti-cancer product. It has been on market as an antibacterial product. But then a further research went on to look into it, and they found that, it has a broad spectrum. And because it has a broad spectrum, because of the inhibitor, it is moderate in terms of toxicity. So it is one of the drugs that is believed that is going to be developed in the next few months towards COVID-19. Can you see where the story started from? Antibacterial, anti-cancer. I know a lot of us will do antibacterial study, but what do we do with it? We just leave it on the table and the student graduates and we write paper and we are fine. But have we met the societal need? No. Instead, it is lying in the shelf. And the good thing about it is that some synthetic chemists have been able to now take this natural product, looked at the structure, studied it, and synthesize it. The reason being that, you see, when you take a natural product and you extract from it, you always have little amount. It comes out in milligrams. And this little amount cannot actually meet 10 or 15 people's need. So what the synthetic chemist did was to look at the structure and formulate this such that it becomes a product that they can start in the lab and end in the lab. So you can see that 3 total syntheses have been made. One in you see from 2020 to 2014. It means this compound can be synthesized in our lab. Another compound is homoharythionine. This compound is known to be used mostly for breast cancer and leukemia, you know, and it's isolated from evergreen tree. And in fact, it is already in the market. It has been approved by FDA since 2012, you know. But the good thing about it is that despite the fact that it is used to treat chronic leukemia, it's also found that it has a broad spectrum for viruses. That is, it can inhibit virus, you know. And because of that, you can see that they now started looking at it. Okay, if it has this, can we try it on coronaviruses and see whether it can inhibit the growth of it? That is where the chemistry is coming from. They did not leave it on the shelf. So please stop leaving your experiment and your work on the shelf. Let it translate into the society. And you can see that 2 milligram scale total synthesis have been completed. That is, again, they have taken this compound from the natural resources, looking at it, studying it. They have started synthesizing this compound again. The last one I will look at is emethine. This is very important because it grows in Nigeria. This particular plant grows in Nigeria. You know, it grows in Nigeria and it has this compound, which is emethine. What is emethine? You will find out that it is a broad antiviral drug that is currently being used. And it has even been used to curb the Ebola virus. There's so much Ebola virus. How come it was being able to curb it? You know, it was through shaping the chemistry of these natural resources. And now it has become a drug that it can be used to curb the virus. And you can find out that the good thing about this particular one is that the concentration that could be 300 times higher in the lungs compared in the blood. So, and you know, coronavirus stays in the lungs. You know, the viruses, they multiply more in the lungs. So if we have a drug that is able to work faster in the lungs than in the blood, then it means we are having a breakthrough as chemists. So what am I trying to say? God has given us natural resources, which is this. We have our natural resources, vitamin C from oranges. But do we have oranges all through the year? Do we have lemon all through the year? Why can't our synthetic chemists start producing synthetic vitamin C such that we bring home the natural and the synthetic and we have naturally derived vitamin C? That is where the call is. You look into the natural resources that we have, you take it into the lab, you synthesize, and you come up with a product that can easily be available all through the year, that is not seasonal, that does not depend on whether there's rain or there's harmattan. We have it all through the year because we have chemists that have gone a bit further to synthesize these compounds. If we look at hypertension, like I said, or non-communicable disease, is a disease that we just look down upon, you know, and it's not written on the face until when that person has a stroke. So you find out that hypertension is a worldwide epidemic. And the most common chronic health problem with a very high risk, because it ends up with renal failure. It starts from stroke, you know, you start feeling numbness. From there, it goes to stroke, high blood pressure, and before you know it, it ends up in renal failure. And by the time it's getting to that point, it has become a chronic disease that you have to live with all through the year. And according to statistics, 25% of the world adult population has hypertension, and it is likely to increase by 2025. But the good thing is that we have a lot of plants that can be used to manage hypertension. A common example is our menta or lemongrass. These are compounds, they have God-given compounds that are inside. So what are our chemists doing that they only look at it and enjoy the smell in the cup of tea and have not gone further to try and isolate these compounds? Because when winter comes or when harmattan comes, these leaves goes off. They are not all through the year. So you find out that we have different compounds that have various structures. You know, I've just put this up, you know, just looking at this particular compound with this quinolene skeletal structure, you know, you can have your diuretic compounds from it. You can have your hypertensive compound. You can have your anti-inflammatory. You can have your anti-obesity, just from one nucleus, just from one family, you know, and just trying to change the functional groups around that particular compound. You can have different drugs in the society. So you find out that what the call is that we take our natural resources, we work in the lab, and then we produce a product that will work for us, which therefore means that please let us stop having research topics that will not speak to our environment, that will not speak to the society. Because if we continue like this, we will not be able to shape the chemistry of our natural given resources that God has given to us for the health and benefit of humankind. And you cannot do that alone. You find out that the problem we have is that, yes, agreed, we have done researches and we have kept it at a stage. We have left it on the shelf. It's because we have not partnered with other scientists. An organic chemist is not seeing an inorganic chemist where that person comes in. It's not seeing a biochemist where a biochemist can help. It's not seeing a microbiologist where a microbiologist can help. It's not seeing a pharmacist. It's not seeing a physiologist. A need therefore arises, whereby when you are seated to map out a research, begin to look at it in a multidisciplinary view. Begin to have an approach that it becomes, this is where I stop. Another person must take it from here. So who do I collaborate with? It talks about collaboration. It talks for us to be able to use our chemistry to shape our natural resources. Like other countries, we need collaboration. This is where we are currently. We have the traditional research and development, but this is where we are supposed to be. This is what is supposed to be for tomorrow. And until we get there, until we begin to look at it, for example, you find out that in chemistry, for example, we are looking at it as academic collaboration. So you find out that, oh no, I just produce papers and I present at conferences. That is the collaboration that it stays. And then I do a little antimicrobial, and then I leave it. I develop skills. I'm not establishing a stable, you can see that there's no stable collaboration network. You go to conferences, you are not seeing somebody in Japan that is working on toxicology, and you can't communicate with that person to say, hey, I have this plant, I have this substance. Can I collaborate with you? We are living in our closed houses, and we are so afraid that our story will be stolen. Who tells you that the story that you have published will not be stolen? Why don't you allow it to be stolen and then you contest for it? I hope that at the end, we will be able to take our traditional R&D that we have here and seated here beyond our ideology, organization, skills, process, analytical view, and we'll be able to look at it and push it for tomorrow and for the next generation. In conclusion, the conclusion is, how do we now take it? That is, how do we marry chemistry, natural resources, and health challenges? Where is the meeting point? We take our chemistry, and then we take our health issues. That is, as a chemist, by the time you are designing a research, you must look at a particular disease that it's going to solve, at a particular condition that you want to use your chemistry to resolve. And then you look at the fourth industrial revolution, because you have to look at the current situation in the country or in the world. You won't want to develop a tablet that is as big as my finger, or you have to take a half cup full, when in these days we have nano sizes. So that is where the fourth industrial revolution comes in. You begin to look at it according to the current revolution, to the current situation in the world, and you begin to shape your chemistry such that it addresses a society. And then you can easily put all this together. And then metabolomics makes it a lot easier for us. Metabolomics study makes chemistry so interesting, such that we don't waste chemicals, we don't waste resources anymore. So you can have your natural resources, you can have your metabolomics, and you have multidisciplinary research, and you will have products. I hope I've been able to challenge you, colleagues, such that we keep on complaining so much that we don't have enough. We don't have enough resources. But let me be sincere with you. You will never have resources, enough resources, if you don't make use and acknowledge the ones that you have to be enough. And with that, I say thank you for listening.
Oh, wonderful. We cannot thank Professor Oyedeji enough. I'm sure she has spoken first to the chemist now, but the applications means she has spoken to every part of humanity. She has been able to let us understand the link between natural resources, the chemistry of it, looking at the chemistry, and how we solve many of the human challenges, which fall within the theme of the conference. Man, that's a wonderful lecture, lucid, precise, and in delivery was especially exquisite. So I want to thank Professor Oyedeji. When I introduced her, I said she's one of our own and one of our best exports to South Africa. I know she misses home, but Prof. Ma, This is part of what we want to do. We want to promote collaboration so that a lot of our colleagues can also prove from this you have mentioned. Of course, she has reminded us that people talk about Nigeria having resources, but she doesn't want these resources to go away. She has called on the researchers to come together, look at issues of multidisciplinarity, not just one person doing things. Let our research solve problems of the world. Our focus has been on the health issue, which of course is very important. You must live first to think of the car you drive and other enjoyment of life. I don't want to do a summary of this wonderful talk so that I don't dilute the taste, which is still very high in the mouth of those of us who have enjoyed the taste. We will take questions, and we've asked using the chats medium for people to send in questions. But for anybody who still have one, can we start throwing in questions? You may also indicate through the chat so that we can allow you in the meantime to speak to your question if you have not sent in one now. Question time. Okay. One question. Dr. Anjorin, please, you can unmute yourself and throw in your question.
Yes, sir. Thank you very much, Mark, for the brilliant presentation. So we've learned a lot from you, and I'm happy that you know our problem in this part of the world, especially in Nigeria, compared to South Africa. So the question is, how do we cope with funding? You enjoy a lot of funding over there in SA for younger researchers in Nigeria, in chemistry area, in microbiology, and other fields that you earlier mentioned. So how do we cope with funding such beautiful researches? Thank you,
ma'am. Thank you for that question. I like it when people first look for funding. You know, everybody, the mind is you first look for funding. But permit me to say that according to Yoruba adage, it says that téèyàn bá domi síwájú á tẹ̀lẹ̀ tútù. Right. You find out that I did not get to where I am today if I was just waiting for funding. Because let me be sincere with you, when you apply for funding, they look at your CV. So if you have only been working and playing around and there's no money, there's not this, and yet you are having money to throw parties about. As a chemist, as a researcher, have passion for what you do. Be able to use your money to work. I could remember in those days, I used my salary. I used part of my salary to do research. I go around, do research. When I see people going out of the country, please, can you analyze these samples for me? By the time my CV was ready, it opened way for me. So I will first advise, let us begin to change our orientation. Let us begin to use what we have within to begin to develop ourselves such that our CV becomes buoyant. Let our CV becomes good. Then thereafter, you can now present this CV and you throw it to the world. You are confident that when you throw it to the world, it can compete with others. In terms of researches, yes, in terms of funding, there are fundings. But then do your homework first. Do you understand? Do your homework first. Let there be enough work that you can compete in your field outside the world. And you find out that when you apply for funding, you will be picked as an excellent person. Thank you.
Yes, thank you, ma. Well, she's just saying, as researchers, we must always learn to invest in our work. You must invest personal funds, time, and all that resources. Oluwayemisi Oshodeyin, please unmute yourself and then take your question.
Yes, thank you very much, sir. Thank you very much, ma, for the wonderful lecture. I really learned a lot from.
Sorry, we are on a global scene. Let us know who Oluwayemisi Oshodeyin is.
Okay.
Introduce yourself.
Okay, sir. I'm Oluwayemisi Oshodeyin. I'm an alumni of Lagos State University Department of Fisheries.
Okay.
Ma, you mentioned of Urua Goga, and the scientific name is Stephalis Ipekauna. I'm not sure of the pronunciation.
Mm-hmm.
And you talked about it that it is being used in curing Ebola because of its anti-protozoa effect, precisely because of its because it contains M18, which actually does that effect. Ma, you told us that it has been cultivated in Nigeria, and we need to begin to look at a research at multidisciplinary view and make impact into our environment. You have to make researches that try to solve solution and speak to our environment.
Your question,
I want to look at it in form of how can this be involved in terms of fisheries, in curing fish diseases, because we'll be talking about disease of humans like hypertension and all that. Is it possible to use these plants to solve diseases in fishes? And I would like to know the local name of the plants, because I've tried to search online. When immediately you mentioned that, I've tried to search online for a local name, I couldn't get it. So I would like if you could give us the local name so that further research could be made on it, ma'am. I'm done, ma'am.
Thank you.
Thank you.
I will start from the last question. You find out that if you go to Book Hill book, you will find it there. And in fact, I made mention of, if you were able or you were smart enough to take a snapshot of that page, right? You could have just done a snapshot and then you will see that there's a reference there. You know, this West African tropical plant. If you look at that particular book by Brookhill, 1985, it is right there, right? So that is that. So you go and do the research. Now, when you look at applying it to fishery, I know in South Africa now, we are moving from using animals as our model. We are moving from using rats and mice as model for testing, for testing of our substances. And they are insisting that we should use fish, right? The technology and the scientific knowledge is being introduced gradually. And the reason is because they found out that it's easier to multiply fish more than these animals. And then they found also, it has been found that fish has the same generic lifestyle with those of rats and animals. So that is a study that is so you see, that is not in my field, but because I use animals a lot and my collaborators use animals. So I was seated in that meeting when the Animal Ethics Committee from National came to introduce this aspect to us. So what I can do is if you send me your email address or you contact me by email, then I can, as this information comes in, I can easily drop it in your email box for you.
Okay, thank you, ma. Ma,
Pleasure.
could you please drop your email, ma, so I can send you an email?
It is just aoyedeji@gmail.com.
Okay.
aoyedeji@gmail.com.
Okay, thank you very much, ma.
Pleasure.
Thank you, ma. We have Dr. Shubola indicating to ask a question. Please unmute yourself, Dr. Shubola.
Okay. Good morning, sir, Mr. Chairman, and a big thank you to Professor Oyedeji for a wonderful and beautiful presentation. We appreciate you, ma'am.
Thank you.
So I'm from Chemistry Department, Lagos State University. In fact, I'm in inorganic chemistry. Ma, I was sort of interested. I got actually interested in the aspect where you mentioned that some of the natural products with biological relevance may have to be synthesized in the laboratory so that we can have quantifiable amount for public use. I just want to ask if it is that most natural product chemists do go through this rigor, or all that they do just for is to identify and isolate this particular compound and leave the rest for the synthetic chemists to sort out. In essence, is it possible for natural product chemists to combine the isolation of the biological active compounds and also proceed to synthesize the compound for public use? Thank you.
You find out that it's possible, but then it means you have moved, this experience is taken over the years. For example, you find out that in my lab, it's possible I have a group, I have a group. And in that group, I subdivide those groups. And because they are subdivided, some do the isolation, some do the semi-synthesis, some do the biological aspect, some, so they do different things. Some do the metabolomics. So it is not something that can be done by one single person. That is where I am coming from. And that is what I'm talking about in this presentation. We must move from a one-man research. A one-man research will take us nowhere. You must move to a multidisciplinary research where you begin to entrust, I will say it again, when you begin to entrust an aspect of that research to another person to take it further, such that a product is generated.
Okay. Thank you, ma'am.
Thank you.
Yes, ma'am.
Chairman, please, can I just use this point to... Can I just use this point to congratulate my friend, my colleague, Professor Boyo, on her appointment as the dean? I know she talked about me during her introduction, and we do chat on Facebook, but I've not seen her. So hi, and God bless you.
Yes, please go ahead, ma.
Thank you. Yeah, I'm done. Thank you.
Okay, Dr. Bankole, you have the floor. Your question, please.
Okay, thank you, ma. I am Dr. Bankole from the Department of Biochemistry. Yeah, Prof. Ma, thanks for the lecture. My question is, the emphasis on collaboration has always been with specialized say botanists, we say microbiologists. I know at a point in South Africa, the government insisted that the owners of these natural resources should be involved. So the locals. Now, and I've been wondering, how do you cite such people in your publication? For example, an old man that informs you that a plant cures a disease. How do you cite such person in in presenting the result of your research? Thank you.
Thank you, Dr. Bankole. I'm glad that I'm at a position to talk about that. I have produced two products now that is currently on pre-commercial stage and will be in the market very soon. It is used for treating arthritis and for mental disorder. You know, those are two products, you know, and it originated from a herbal practitioner. You know, I met with this man and he talked so much about his plant and all that. And my work with him has expanded. I think I've worked with him for over 6 or 8 years now. Yeah, I've been working with him for 6 or 8 years, but he passed away last year, you know. But the good thing is that we have publications. His name is Mr. Ruben. When you check my profile and you see some article, you will see his name there. Ruben Mateu. You know, I have about either 6 or 8 publications with him. And the royalty that will come from our two products will go to his family. So you don't actually sniff out the person that actually introduces you to a product. So the student that worked on it becomes the first author. He becomes the second author. Any other person that did biological work becomes the third author. I don't need that position. I'm usually the last author. So always make sure that you put the person, that the indigenous person that gave you the information, put them on your article. It goes a long way. In fact, in South Africa, you will not get funding if you don't do that.
Well, thank you, Prof. Ma. I've searched through the chat box, no other question available. But I understand that the Dean wants to make some intervention. Professor Boyoma.
On mute. Okay. I think she's muted.
Okay. Unmute Professor Boyo, please. Can't hear her.
Hey, she's talking and we can't hear. She's on mute.
We can't hear her. What is the issue? Please unmute her. Okay, maybe put a call through to her to let her know we are not hearing her.
Oh, we can't hear.
Maybe.
Okay, I think she's on now. Yeah.
Okay.
Oh, she's muted again.
Dean, if you can hear us, you are not hearing. I think it's a network. You can use the phone. Please use your phone. Call me and then start talking. Or I call you and you start talking to me. She's still not able to talk. So I'm trying to call her so that we can link her up. Maybe there's...
Okay. Hello, can you hear me?
Yes.
I can hear you loud and clear now.
Yes. I'm using my phone now. I don't know why I can't hear from the computer. Yes, I want to thank Professor Bola Oyedeji for the challenging and thoughtful talk and information given to us this morning. It was really a splendid time. I remember when we were both at we were both using the same office, and where we started together. I want to say this morning, listening to you gave me another insight about you of leaving Nigeria to South Africa. And what you have told us this morning is challenges to the undergraduates, the postgraduates, and even we that were still researching. I want to say a very, very, very big thank you to you. When you say you use your money for research, I was aware of it because we're all growing up together and in Lagos State University and being in the same office. I want to say thank you very, very much. And I'm sure next time we are going to invite you, by the grace of God, we have more to learn from you. Those in chemistry, although I'm a physicist, but you have taught so many of us this morning. Thank you. And my regards to Prof. 2 and everybody. Thank you very much. Thank you. Chairman.
Thank you.
Yes, thank you, my friend. Thank you.
Thank you.
The Dean and Professor Yedeji, well, you know, when ladies meet, they have a way to connect. They want to renew the old time. So now let's just unmute the people to just give Professor Yedeji a round of applause for a beautiful time. We have enjoyed the question and answer session. Please, let's just, as we she's done the beautiful work, and then she's discharged and acquitted to take her seat. But she's not leaving us because I'm sure she's part of what she has dedicated today for us. Unfortunately, I've just asked that from the Covenant University. So because of that, we'll go for a coffee break, and then when we come back, we break to a technical session. Thank you all for participating. Thank you all. So I think that's really good. Yeah, the link for the technical sessions and the various rooms have been shared. I hope we have a nice coffee break. Let's prepare to go for the technical sessions. You can check the chat room. It will guide you as to link up to the various rooms where the technical sessions are taking place. Check the chat box, the chat room. It will guide us to link to our respective room for the technical sessions. We are having today the physical and biological. And we continue to welcome our international participants and colleagues all over the world. Put in mute.
Hello, good morning. You are welcome to room 2 for physical sciences. My name we will start now. And let me remind us that we have 7 minutes for each presentation. Can I have abstract number 103 delivered by Mr. Macaulay? Sorry, Mr. Macaulay. Mr. Macaulay. Hello, Mr. Macaulay. Mr. Macaulay.
Mushe, kini ẹni ìlànà náà, Dr. Bankole. Mushe CB Latif lánàá. Gbọ́ voice mi. Sorry.
Sir, your room, they are presenting. And I don't know more hosts. No, some room can Mumbo. May I kindly invite the presence of Professor Moses Akobi to share the technical session for Physical Science Room 1.
Yes, thank you very much. I want to welcome all of us. We have been welcomed to the Faculty of Science conference. I want to use this opportunity to welcome all of you to room 1, where we're going to be taking paper in physical sciences. Of course, we know how critical physical sciences are to national development. It's a bedrock. So I want to believe that as we ruminate and discuss together in this room this morning, afternoon, it will be a very interesting session. We have for our room, we have 5 papers to be taken. 1, 2, 3, 4, 5, 6. No, I beg your pardon. Physical Sciences, Room 1. Sorry, because I'm chairing another panel, I have to use handheld devices. So we are starting from paper 116. Am I right? 116 down to 152. Please, can you help me confirm? Hello? Do I have Dr. Adewusi Mustafa in this room? Hello? 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 I need response. Dr. Onori, can you unmute yourself and respond so that I can know that I'm being heard?
Yes, sir. Good morning, sir.
Okay, good morning. Very good. So please, for now, keep yourself unmuted so that there can be communication. I didn't know whether anybody was hearing. So I'm asking that I have taken apology that I'm using handheld device, so I'm unable to navigate as easy as it will have been on my laptop. So the session we are in here, room 1, we are taking physical science paper, and I'm trying to confirm those who are ready for presentation. So we should be having Mr. Kakwa Yorinde. Am I right? Are we taking paper 41 down to 55? Hello? Hello?
We can hear you, sir.
Yes, I'm trying to confirm the presenters at this our session. do we have Mr. Kakwa Yorinde, Mr. Atombiyi, Gabriel, Mr. Ahmed Abdul Kadir, and Dr. Mustafa Rilwan? As well as Mr. Asogwa Oluchuku. Are those people in this room for presentation? Hello?
Probably they are not here. Maybe that's why there is no response.
Okay, yes. Is there anybody in this room who wants to present? Let me know your name so that I can check where your paper is.
Yes, good morning, sir.
Good morning.
For this room, I'm abstract number 116. For this room,
116.
That's with to Paul, survive.
I beg your pardon. 116. I'm trying to locate it.
Was
116, okay. That will be Mr. Wetopol.
yes, sir.
Am
yes,
I right?
Exactly.
Mr. Wetopol, okay. So
yes.
Perhaps I was on the wrong paper listing. So let me go over it again. 116 is the first paper. You are here. 119 means Nae Navia. Are you here?
Yes, Professor, I'm here.
You are here. Okay. Then paper 120 means Amwa Agiapong Rosina.
I'm here, please.
All right. Thank you very much. So we already confirmed 3. I think we should just go on, and then we'll be coming back. So paper 116, I would like you to commence the presentation. We're going to spend 7 minutes for presentation and 3 minutes for question and answer. So can you please go on?
Okay, sir.
You can share your you can
It's
share
my
your
screen, sir.
Huh? Hello?
Can you see my screen, sir?
It's sharing. It's loading on my end.
We can see your screen.
Okay, so carry on, please.
Hello, sir. Can you see my screen?
We can see your screen.
Go on, please. Yes, we can see your screen now. Please go on.
Yes.
Mr. Honore, please, can you help us as timekeeper?
Okay, sir.
Thank you. 7 minutes. Thank you.
All right. My name is my name is Paul Wito. I'm a co-author with Can I continue, sir?
Please go on.
All right. My name is Paul Wito. I'm a co-author with Professor Benjamin Aribisala. I'm a funded level student of computer science department. Lasu. So the topic of my presentation is design and
I think our presenter system is frozen or connection. Mr. Paul?
Yes.
He has network issue. He's no more on the platform. Okay, so we have to take another person.
Yes.
So paper 119. Can you come up?
Yes, Professor, I can come.
119 means Navia
Yes.
V, assessing vulnerability of small-scale fisheries through the lens of water quality in Chilika Lagoon, India.
Yes.
I welcome you for your presentation. Thank you, madam.
Thank you so much.
Seven minutes, please.
Can you see my
You can
screen?
share your screen. Okay, yes, you're already sharing your screen. Yeah, we can see your screen now. So please, go on.
So, hi, my name is Nabia Binayar, and I'm a graduate student in Sustainability Management from University of Waterloo under the supervision of Professor Pradeep Nayak. And I would like to start this presentation by taking you to the imagination of beautiful days when you tasted your favorite seafoods. Unfortunately, those days are numbered due to your actions in the ocean. Fishing communities are threatened. Even if you do not live anywhere near the ocean, you're affected by it. The ocean gives us food, it supports nutrition, provides pathways between continents, and it even offers fun and recreation. So, my passion had driven me for fisheries to change. And my research is on assessing vulnerabilities of small scale fisheries through the lens of water quality in Chilika Lagoon, situated on the east coast of India. And the research is a part of B2B Global Partnership supported by SSHRCC. FAO defines small-scale fisheries as a dynamic and evolving subsector of fisheries, employing labor-intensive harvesting, processing, and distribution technologies to exploit marine and inland water fishery resources. So typically, men are engaged in fishing and women in fish processing and marketing. The study synthesized in 2015 by FAO looked at livelihood and economic contributions of capture fisheries globally. Approximately 120 million workers are directly dependent on small scale fisheries for their livelihood. 97% of these people live in developing countries, and among them, more than 90% of them work in small scale fisheries subsector, and 47% of the total workforce is women. And can you believe that an estimated 5.8 million fishers in the world earn less than $1 per day? Small scale fisheries provide directly or indirectly livelihoods to a large number of people. They sustain life, support jobs for millions of people worldwide. They feed communities and countries and are vital in addressing climate change. So my study location is Chilika Lagoon, Asia's biggest brackish water lagoon situated on the east coast of India. Several hydrological effects in the lagoon, such as runoff from unregulated depleted catchment, silt-borne freshwater discharges, lagoon water exchange, have dramatic and unpredicted consequences. These changes in the lagoon ecosystem have turned out to be a cause of concern for local and national governments to dredge a new seamouth in 1980. Along with this, rising market for the shrimp aquaculture has served as a rapid driver for social ecological changes. The consequences resulted in difference in water flow rates, pollution, salinity, variation in the disruption of water balance. So past research in Chilika highlights the adverse impact of these key environmental changes, contributing to the decline in fish production and income, impacting their livelihoods. Then shrinkage of water distribution, salinity, biodiversity loss. So my research study examined the vulnerability in coastal fishing communities of Chilika Lagoon due to water quality degradation and assess how to achieve an adaptation strategy to make the communities less vulnerable and more viable. And the three objectives that guided my research is understanding the process of water quality variation in Chilika Lagoon and examining vulnerability issues faced by the coastal communities due to changes in water quality, And finally, analyzing various coping and adaptive strategies of fisher communities and their potential for creating viable small-scale fisheries. And my research method follows a kind of mixed approach, including qualitative analysis and quantitative analysis, incorporating in-depth literature reviews through Zotero software and various case studies from the past study reports, as well as document analysis and secondary data sources. Further assessment of various water quality parameters such as water depth, turbidity, salinity, variation, and then biological oxygen demand, various levels of nutrient disparity, and trace elements in chlorophyll are analyzed from the past data recorded. Diverse human-induced and natural phenomena cause water quality changes, leading to ecosystem variation, as well as adverse impacts on the fisher communities. Hydrological parameters demonstrated in Chilika had observable changes in both seasonal and spatial scales. So the water quality changes results in social ecological changes, which ultimately affects the livelihood of communities dependent on these resources. The fishing sectors was affected by biodiversity loss, water pollution, food insecurity due to the low light penetration or hindrance in photosynthesis and heavy sedimentation, along with less oxygen levels creating hypoxia, eutrophication, and algal bloom. Current environmental social market changes put communities at risk and in vulnerable positions. Specific outcomes of the impacts of water quality change as a driving force are income loss and livelihood, then food insecurity, lack of access rights, intensive fishing, and increased indebtedness, which leads to displacements and adverse mental conditions. So adaptations are needed in minimizing the impacts of environmental change on fish stocks and biodiversity, utilizing a structure that tends to address both short-term and long-term impacts and goals. Water quality testing can be a key measure needed to safeguard coastal habitats from the present-day stresses, eliminating activities that result in water pollution. Sustaining coastal fish production around the islands depend on good land management practices to maintain the quality of coastal waters and habitats. Outmigration has become the only livelihood option for fishers in Chilika by relocating to cities to avail employment opportunities. Then intensification and extensification was done through changing gear selections without restriction on the species to catch, or like traveling to long distances for fishing and catching all the available species that are given to them. Then diversification through activities within the fishing sector, developing non-fishing occupations or engaging women and children in income generation activities were also employed. The research helps to find sources of ecological threat that helps in proper utilization of resources as well as to develop proper management. It also highlights issues faced by marine environment and the resource use challenges. It determines the coastal water and environmental conditions. And in addition, analyzing the specific adaptations and responses of coastal communities to the socio-ecological change leads to novel governance approaches for better dealing with vulnerability and strengthening of community. Overall, the research will potentially contribute to the viability of coastal fisheries, marine environment, and fishing communities. Such benefits will extend beyond Chilika, and results can be replicated in a variety of similar coastal contexts. So hopefully, I expect that my research findings will limit the exploitation of coastal resources. Thank you.
All right, thank you, Madam. We are happy for this very wonderful presentation, and I hope that some of us on this side will be able to touch base with this kind of research you are doing and even enter into certain interdisciplinary partnership. I want to open the floor if there are questions for Ms. Navia, I beg your pardon. Any question, please? You can show with raise of hand, and then our host can unmute you. Any hand? Nobody is raising hand. So I want to believe that there is no question for Ms. Navia. So once again, we want to thank you very sincerely for being part of our conference in Lagos State University, and the presentation you have made is such a wonderful one. And we believe that it will find relevance in the things we do. We have a very strong Department of Fisheries in Lagos State University. We have won a lot of grants, and I believe that the department and some people working on those projects can actually partner with you to extend some of the things you are doing there, to our own base here. So once again, I want to thank you sincerely for being with us on this conference. Thank you.
Thank you, Professor, for this opportunity. And I thank you and Professor Akintola on behalf of University of Waterloo and Professor Pradeep Naik and our VTP team.
All right, thank you. So now we're going to take paper 120 by Ms. Amwa Agiapong Rosina. It's on building local resilience to climate change vulnerability in small-scale fisheries communities of Lake Volta in Ghana. So Ms. Amwa Agiapong Rosina, you are welcome.
Thank you, sir. I would like to share my screen. Just a minute, please.
Yes, please go ahead.
Please, can you see my screen?
Yes, we can.
Okay, good morning, everyone. My name is Rosina Mwe-Japon, second-year master's graduate, second-year master's student from the University of Waterloo, Canada. And my research is on ways local resilience can be built to climate change vulnerability in small-scale fishery communities of Lake Volta, Ghana, and it's being supervised by Professor Pradeep Naik. Actually, this research is part of an ongoing project from the V2V Global Partnership Group and is supported by the SSHRCC. So let me give this scenario. Imagine we're a community made up of fishers who depends on fishery for survival. Then we wake up one day to face the unexpected. There is an unpredicted heavy rainfall, rise in temperature, floods, or even drought. Of course, we know it's caused by climate change, which is a global threat to human lives and environmental sustainability. So as a vulnerable community has become prone to diseases and other social losses, what can we do to be able to cope and adapt to the situation at hand? Or what policies or mechanisms can the government or even all sectors put in place for us to become viable again? It is for this reason my research is on ways or how local resilience can be built in climate change vulnerability in small-scale fishery communities of Lake Volta. So I chose Lake Volta because from the map, you can see that it is the largest human-made artificial lake in the world, which covers about 8,502 square kilometers by surface area. And it contributes to about 90% of the inland fisheries in Ghana. It actually came as a result of the hydroelectric power being generated by the Akosombo Dam in 1961 to 1965, yeah. And the common fish species found in the lake are the catfish, the tilapia, as well as the perch. So according to the FAO report in 2015 stated that 12% of the world's population depends on fisheries for survival, while 90% are into small-scale fisheries, of which half are women. So the SSF in Lake Volta provides job opportunities to the community people through making and repairing of boats, owning boat and gear. As you can see from the picture, it also helps our women to be able to trade in fishes to generate income for themselves, and also create, it also serves as a source of food security. And at the same time, it contributes about 1.2% of the total GDP of the country through foreign exchange earnings, revenue, among others. However, the impact of climate change affects the livelihoods of these people living in these fishing communities, especially when it comes to food diminishing. When you look at the right-hand corner, the picture there, in Ghana, we have two seasons. We have the dry season and we have the wet season. So imagine there is a rise in temperature, which causes the water to become warm. Now, when this happens, the fishes are not able to spawn, but those who are able to survive, they are not able to breathe in air. They lose their air and shrink in size. When they shrink in size, some of them eventually dies, and those who are able to survive are not able to spawn or reproduce, thereby decreasing the food production in these communities. And when this happens, not only does it affect the communities, but it also affects the country and the world at large. So it is for this reason my research aims to investigate the fishing community's view on how local resilience can be built to climate change, and also examine the achievement of viability in these fishing areas. So using past review literature as my secondary data collection, I employ the I-ADAPT framework. The I-ADAPT is assessment based on description and responses and appraisal for typology. It is actually a thinking framework tool which provides a useful understanding to the climate vulnerabilities experienced by these fishing communities, the challenges to building resilience to them, and the nature of governance responses and how they interact with each other. So with my results, I had it in two parts. That is the impact that has on the people and the way forward. So a study conducted by Nayak and Bekis in 2019 shows that vulnerability comes as a result of a loss of fishing community resilience and the adaptive capacity of a community to be able to cope and adjust to stresses caused by either political, social, or even environmental changes. Now, the absence of well-being, livelihood capitals, and resilience through the impact of climate change poses a significant threat to the livelihoods of the people. They lose their source of livelihood. Their physical infrastructures are being lost. Their roads, hospital, homes are being lost, and it poses threat to their health. They are prone to diseases and even accidents. And the way they used to live before, they will not be able to live as they used to. So their social lives is also impacted. Now, how can, moving forward, the local fisher communities will be able to adapt to climate change by trying to channel their resources and energy to something else, like in a form of maybe trading, finding other alternatives like trading or cattle, livestock rearing, or even into farming. Then also using their traditional technological knowledge by observing fishing holidays. When this happens, they allow the fishes to rejuvenate back to their natural production levels. And finally, when there is a severe impact of climate change, it allows the people to move to other places in search for greener pastures. Then in conclusion, to adapt to an unending occurrence of climate change impacts, there is the need for the government to have a change in policies towards enhancing local knowledge and increasing the participation of community members in policy formulation and implementation. Also, there should be a multidisciplinary approach involving all the sectors, like the public and the private sectors, the Department of Fisheries, the Ministry of Environment, Technologies, Science and Innovation, the community-based organization, the traditional authorities, even the small-scale fishery communities themselves, and the NGOs. They should all come together to enhance, to help recognize these complex problems in managing the climate change response in small-scale fisheries of the fishery communities in the water. And then finally, capacity development by empowering these stakeholders through training, education, exchange of collaborative programs from our universities, research centers, should be strengthened and enhanced to help small-scale fishery communities in these vulnerable communities in Lake Volta become viable. Thank you so much.
All right. Madam, thank you very much for this wonderful presentation from University of Waterloo. We thank you for joining our conference, and this is another good work on fisheries. Just like I said initially, we love the kind of things you are doing, and we believe that it will really play a very significant role as you have come to present this work in our conference, especially with our gurus in fisheries in this part. Do we have any question? Checking, no hand is raised yet. Please raise your hand if you want to take any question.
Yes.
Oh, you are not making use of the hand raising on the platform. If you click on participants, somewhere there, you will see raise hand. And then the host will be able to unmute you.
Participants.
But anyway, you have already unmuted yourself. Yes, that is Oluwayemisi Osho. So can you go on with your question? You're already unmuted.
Please, I'm sorry to cut in. Hello.
Yes. Hello.
Please, I'm so sorry to cut in. Before they answer the question, can I record it just for? I just want to record it for future use, if you don't mind.
Your presentation?
No, I mean the questions.
The question, okay.
Yes, please, for future use.
Okay, allowed to record. I've allowed
all right,
you.
Thank you so much. Thank you.
Yes,
please, you can go ahead. Yeah.
Oluwayemisi, please go ahead with your question.
Okay, my name is Oluwayemisi Osho from Lagos State University. I would like to ask, you made conclusions, you made about 3 conclusions, probably recommendation. Before I want to ask, how can policy formation, how can we do policy formulation and implementation? How can it be done? Like, you use Ghana as a point of, how can this policy be formulated? Who are the people that will be involved? How can it come to success? Because I think we are really lacking in that area in Africa. So how can we go about it? I would like you to make more emphasis on it.
Okay, so thank you so much for this question.
I hope you got my question.
Yes, please, I do get you. So this is one of the problems that Africa, especially in Ghana, is facing, because when it comes to policy making, especially at the national level, they don't involve the small scale fishery communities. The reason being that maybe they have issues with limited resources, and sometimes they see, how Africans, how they tag fisher folks as being poor. So this the resources that needs to be channeled into helping them and empower them, because of political reasons, they one way or the other misuses these resources. So in my opinion, this research actually is still ongoing. I'm not done yet. But then in my opinion, when the national level, when all these public sectors come together to engage the community, to engage the community people in their policy making by going to them, asking them the needs that they want, the things that they can do to be able to help or build them through decision making, policy making, I think it will be able to help them one way or the other. That is my opinion, though. But then though it's my word, but then if anyone has anything to add to, they're welcome.
Okay, so if I get it right, you are trying to tell us that we should involve fisher folks from the grassroots.
Exactly. Exactly. Okay. Thank you so much.
All right, thank you very much, Ms. Rosina.
Thank you.
Thank you, sir.
Once again, Once again, we appreciate you. Ms. Oluayemisi, we thank you for your question. Once again, we appreciate Ms. Rosina for joining us in Lagos State University Faculty of Science International Conference 2020.
Thank you so much for having me too.
Yes, you're being part of this conference has added a lot of value to what we are doing in Lagos State University, and we hope for effective and efficient future relationship. So you can share your screen and stop the recording that I gave permission for. Thank you very much.
Thank you so much, sir.
Yes, we love your face. Thank you for coming. All right, so now I want to, our first presenter who had network issue is okay now. So please, I want to crave your indulgence that I go back to him, Mr. Weto Paul Sebayi. He is going to be making presentation on design and implementation of an online tutorial platform for higher institutions. Mr. Weto Paul Sebayi, you are welcome to Faculty of Science International Conference 2020. Please go ahead with your presentation. 7 minutes. You can share your screen.
Much I do appreciate that. Can you see my screen now, sir?
Yeah, please go ahead.
Hello, sir. Can you see my screen?
Yes, please go on. We can see your screen. Mr. Paul, please go on. We can see your screen. Oh, he has dropped off again. I think his network is really struggling with his network. I'm searching for him on participants. He's no more on the participant list. So please, I want to crave your indulgence. We're sorry for that. You know, these things, we don't have control over them. So I will quickly take paper 121, paper 121 in physical sciences is to be taken by Miss Sheikyi Joyce.
He's back.
He's back, okay.
Is back.
Mr. Paul, your network is really struggling. You are really struggling with network. Mr. Weto? Hello? Yeah, so you need to be very fast now. You have taken a lot of our time because of the network issue. So please quickly go on. Thank you. Very well. Go on.
Yes. Yes, sir. So can you hear me, sir?
Mr. Paul, please go on. Time is going. We are hearing you. We can hear you rather. Unfortunately, it's drop off again. So paper one, we have to keep you to the last. So let me take paper 121. Ms. Sheikyi Joyce, adaptive responses of small-scale fishers to the vulnerabilities resulting from oil and gas activity. You are welcome to Lagos State University Faculty of Science International Conference 2020. Ms. Joyce, please go on with your presentation. Thank you. 7 minutes, please. 7 minutes, please.
Thank you. Sorry, I need to share my screen.
Yeah, please go ahead. Yes, we're waiting.
Okay, sorry. Can you see my screen, please?
Not yet. We can't see your screen, madam.
Okay, sorry. I'm still trying to connect. Can it be seen now? Sorry.
Not yet.
No. Okay.
Can any other person see our screen? Well, your screen is not coming up. I think you have to go ahead.
Okay. So, hi everyone. My name is Joyce Sechi, and I'm also a student of the University of Waterloo, working under Professor Pratip on the V2V Global Partnership. My research focuses on the adaptive responses of small-scale fishes to vulnerabilities resulting from oil and gas extraction in Ghana. So small-scale fishes, as we know from the previous presentation, offer a lot of job opportunities to people engaged in capture fisheries, especially those from the developing countries. It supports livelihoods and then provides medicine and then food for a whole number of people across the world. However, past studies have shown that small-scale fisheries encounter issues of climate change, unfavorable trade policies, oil and gas production, especially with those located around coastal communities. And this has called for various research into how activities of oil and gas companies offshore affect small-scale fisheries. So in Ghana, small-scale fisheries support about 2.2% of Ghana's population, with about 135,000 fishers working in the marine subsector. However, Ghana started oil and gas production in 2010, and researchers have explored how oil and gas activities impact fishers' livelihoods and total well-being. So studies have talked about issues of seaweed, other grievances that occurs during seismic surveys offshore, issues of declining incomes, high cost of operation. And so my research aimed to investigate some of these vulnerabilities and also to find the adaptive responses fishers take in response to the identified vulnerabilities. And one striking thing I found during my research was that most adaptation studies has been taken in the field of climate change as opposed to oil and gas activities. However, impact of climate change on fisheries connect to these impacts of oil and gas activities. And so using the I-ADAPT method, which is assessment based on description and response and appraisal, I studied the governance systems, natural systems, and social systems, which combines to impact livelihoods of small-scale fisheries located around coastal areas. And so from the studies, first of all, vulnerabilities such as oil spills, release of toxic gases into the atmosphere, debris from FPSOs, that's the floating production, storage and offloading vessels, and high issues of inequalities, decreasing well-being, health risk were investigated by previous researchers. And in response to these vulnerabilities, fishers usually undertake livelihood diversification. And so they go into aquaculture farming, they go into cocoa farming, especially in Ghana. People are into carpentry and livestock rearing as a means of obtaining alternative forms of income. Other fishers also try to intensify their fishing efforts by exploring other parts of the sea and then using GPS and other equipment and technology that helps them to obtain a lot of fish catch. Others resort to migration, so they move to other areas in search of new jobs and then in search of better fishing grounds. People try to access loans. There is also issues of trying to enhance their fishing skills by undertaking training. And so in conclusion, this research says that attention should be given to fishers who complain of such vulnerabilities, and they should also be included in decision making, like my friend mentioned earlier on. Research on adaptation, especially with regards to oil and gas vulnerabilities, must be undertaken. It should be enhanced in order to understand issues of oil and gas vulnerabilities and how fishers cope, in order to support stakeholder engagement, corporate social responsibilities, and all other interventions aimed at improving livelihoods and well-being of fishers. Thank you.
All right. We are grateful for your presentation. It's such a very good one. Thank you for joining us in Lagos State University Faculty of Science International Conference 2020. Can I open the floor to any question? Any participant that wants to ask question, just click on participants, and somewhere there you will find where you can raise hand, and we can allow you to ask your question. Anyone? Okay, no question. So Ms. Joy Sekie, once again, on behalf of the chairman of the local organizing committee of Faculty of Science International Conference 2020, the dean of our faculty and the vice chancellor of the university, we are grateful for your being part of our conference this year, and we believe that the presentation you have made will go a long way in improving the state of things in the coastal Africa. Thank you very much.
Thank you.
Can we? Yes. I will call on the next paper, that is 123, Artificial Intelligence, Mr. Olusegun Ogunsanwo Abayomi, Artificial Intelligence and Academic Achievement. Are you here in the room? Mr. Olusegun Ogunsanwo Abayomi.
Hello, good morning.
Okay, it's already afternoon, so you have 7 minutes to present your... Yes, we're with you. 7 minutes to present your paper, please. Thank you.
Yes, we are trying. Okay. We are trying to share our screen.
Please quickly do that. You are enabled.
Hello, sir.
Yes, we're with you. Any issue?
We are having a technical issue presently, but we'll get back to you as soon as we are able to rectify.
Okay, then you put up on the chat. You post it on the chat room so that we can take you then. All right, so let's take the next paper. Paper 126 is to be presented by Dr. Ometon Olufunmilayo. Statistical analysis of the variation in the occurrence of rainfall pattern in a tropical location, southwest Nigeria. Ms. Dr. Ometon, please, you are welcome to present your paper. Thank you. Are you with us on this in this room? Dr. Meton? Dr. Honore, please, you will be helping me to check them. Dr. Meton is not here. I beg your pardon. So we go on to next one. Paper 145 is to be presented by Mr. Chibueze, Timothy Chibuike, and the paper is on half metallic ferromagnetism in half Usla AUMN SNTE. Are you in, Mr. Chibueze? Timothy?
Yes, I'm here.
Okay, please, you have 7 minutes to make your presentation. Thank you. You're welcome to our conference.
All right, thank you very much. Let me share my screen.
Hello?
Yes,
Okay.
we can see your screen. We can see your screen. Please go on.
Oh, good. Okay, my name is Chibueze Timothy from the Department of Physics and Astronomy, University of Nigeria, Nsukka. I am here to present a paper titled Half Metallic Ferromagnetism in Half Usla AUMN-SNTE. This is my outline. Spintronics is an emerging field of solid-state electronics which tries to exploit the intrinsic spin of these electrons that are already in use in normal electronics. And this has shown to be useful in so many applications like in hard disk drives, random access memories, magnetic tunnel junctions, and some other uses. This is really an emerging field, and our work here is to look for materials for these applications. And then we realize that there are a class of materials called half-Usla compounds, which have shown to be attractive for this purpose. And we have looked at these half-Usla compounds because of their magneto-optical Kerr effect, and then their magnetic tunnel junction applications. And then we search for a material that can satisfy the criteria for application in this spintronics, which includes that this material will be half metallic. That means that it will be a metal in one spin channel and a semiconductor in the other spin channel. And another criteria is that this material must have what we call the high Curie temperature. The Curie temperature must be high above room temperature, so that this material do not degenerate when there is a high temperature in the electronic device. So we realize that this AUMNSN has what we call valence electron content of 22 and is supposed to be half metallic. But interestingly enough, crystal orbital Hamiltonian population analysis have shown that it is not half metallic because it can only be half metallic at electron content of 22.2. And so we say, how do we make this material, AUMNSN, to become half metallic? So what we did was to look for how to add 0.2 electrons per formula unit to this compound. And that we make the material to have fully occupied bonding orbitals and then fully empty antibonding orbitals. In our calculation, we followed a theoretical approach to predict this material. We are using quantum espresso code to solve the Kohn-Sham equation within the framework of DFT, and we employ GGA-PB in particular, which works fine for solids, ultrasonic pseudopotentials, and energy readback of energy cutoff of 60 readback. So what we did to be able to have this extra 0.2 electrons, what we did was that we modeled a 2x2 primitive unit cell of this half-Usla AUMNSN. And then we substituted one SN compound, SN atom in this compound, and then replaced it with tellurium. And then we did our calculation with studies on these materials, and we realized that this material has become half metal. This is the model we have. On the right is the undoped compound, and then on the right is the doped compound, on the left is undoped compound. Here is our result. We studied, because whenever we do a theoretical model, we must confirm that this material is stable. What it means is that it can actually be synthesized in the laboratory. So we check the elastic properties to see that it conforms with the bond stability criteria. And our result here shows that it does. Then we also went to look at the density of state of this compound. And you can see in the upper channel, the blue line, you can see there are finite states at the Fermi level. Fermi level is the vertical broken line there. So there are finite states, but when you look at below it, there are still finite states. That is for undoped compound. But when we doped it, you can see there are finite states on the upper line, the spin up, and there are no states as spin down. You see that doping with tellurium has really transformed this material that is magnetic, that is metallic, on both spin, has now become semiconductor in the spin down channel. So that is what we have achieved. And then we try to look at how robust is this ferromagnetism in this material. We apply the pressure up to 24.91 gigapascal, and you can see from the spin down, the red line, that this material is still a half metal. So this is the projected density of state on the atomic orbitals, and this is the band structure that tells us that if you look at the figure D here, you see that the spin down, the horizontal broken line, the Fermi level, there are no states crossing that Fermi level, telling us that this material is a semiconductor in the minority spin, while it's a conductor in the majority spin, the B of this figure. So here we see that the majority of our magnetic content, magnetic moment, lies on the manganese atom. Now, we also did a magnetic phase diagram of this compound and realized that if you continue adding tellurium, replacing tin with tellurium, at certain critical point, you are going to realize that this material changes from ferromagnetic compound to antiferromagnetic compound. And we see that this concentration is too high. What we did is just about 0.125, but at 0.46 is this transition, showing that this our material is hardly safe to be applied as a ferromagnetic compound. Now the conclusion. The compound, the tellurium doped AuMNSN is mechanically stable up to 24.91 gigapascal, and this material is ferromagnetic half metal up to a pressure of that 24.91 gigapascal. We calculated the Curie temperature and got a Curie temperature of 725 Kelvin, which is high above the room temperature, which is satisfactory enough. And we also got a transition from ferromagnetic to antiferromagnetic as 46% tellurium concentration. And this gives us the confidence that this material should be synthesized by the experimentalist, and we hope that it will work fine for spintronic application. Thank you for listening.
All right. We're grateful for your presentation. It's such a wonderful one. Before we comment, let me ask whether some of our participants want to ask questions. Please, if you want to ask questions, just raise up your hand using the provision on when you click participant, then somewhere there you raise hand and we'll be able to call you to ask a question. Any question for Mr. Timothy Chibweze? None. Okay. Well, I quite appreciate the work that you are doing, which you have presented to us. It's such a good one. And I love this kind of fabrication that you are making. And let me not ask as a question, let me just make it as a comment. we're in need of beginning to develop our own technology, transfer the technology from the west down this side. And I think this kind of thing you are doing much relevant in building some of our own things locally from here. So I want to encourage you that it's a good work that you have done. You need to move on, to begin to bring up this kind of idea so that we can begin to fabricate and manufacture some things by ourselves on this side, rather than depending on importation of everything, including toothpick, that we do in Nigeria. So, Mr. Timothy Chibese, I want to thank you very deeply for being part of our Faculty of Science International Conference 2020. We are glad to have you. Our regards to them in University of Nigeria in Nsukka when you return. On that note, I want to...
Thank you very much.
Yes, you are welcome. I want to call on the next paper 152. He has notified me that he's on the ground. He's on ground. Dr. Keshiro Olasunkomi, please, can you go ahead with your presentation? You can share your screen. You're already enabled. Thank you. While you are doing that, please, I want to recognize one of our very senior professors who is with us in this room, Professor O. Faguaro. Prof, we recognize and welcome you to our room, Physical Sciences. We thank you for being with us. Thank you, Prof. So, Keshiro, can you go on, please? All right. Your screen is already shared. Please go on. Dr. Keshiro, we cannot hear you. And you're already unmuted. Is it only me? Dr. Honori, can you confirm, please? Can anyone confirm whether Dr. Keshiro is being heard?
No, we cannot hear him. Like his
Dr. Keshiro, we can't hear you. And we heard you before, so what happened? Hello? Dr. Keshiro, we can't hear you. Oh, my. And you have your screen shared. What do we do now? We can't hear you, so we have to move to another presenter.
Good afternoon.
Okay.
This is hello.
Hello.
This is Ogunsanwo.
Okay. Ogunsanwo, paper
You
what?
can present now.
Paper what?
Paper 1, 2, 3, sir.
Paper 1, 2, 3 is not listed for this session. 1, 2, 3. Okay. Artificial intelligence
Paper
and
1,
academic
2, 3.
achievement.
Yes.
Yes, artificial intelligence and academic achievement. Please go on. Share your screen and go on, please. 7 minutes. 7 minutes,
yes.
please. Keep to time. Thank you.
Okay, sir. Can you see our screen now, sir?
Yes, go on, please.
Okay. Good afternoon. My name is Kazim Benga. I co-authored a paper with Mr. Ogunsanwo Abayomi O on artificial intelligence and academic achievement. Artificial intelligence, as you all know, is a technology that is concerned with making machines to perform activities that involves cognitive processes with degree of high accuracy and speed. In most instances, they are better than women. The technology integrates big data. I'm talking about artificial intelligence. It has in itself big data and the machine learning or deep learning with a computer algorithm in such a way that the machine can learn from large amount of data and apply what it has learned to solve a real life or future situation. Artificial intelligence, as we all know, has become a vital part of human existence, and it has permitted every facet of human life, in which academics is not an exception. And the previous study have shown that artificial intelligence is capable of reducing the academic stress that people in the academics are facing. But despite all these studies, in the field of academics, artificial intelligence applications has not been fully utilized. And this has become a source of concern. Hello, can you hear me?
Yes, please go on. We are hearing you. We can hear you.
So from this, we call our objective of study. Though our main objective is to evaluate the influence of artificial intelligence on academic achievement. In Nigeria, where we use Federal Polytechnic Ilaro as a case study. And from this main objective, we try to pull out some specific objective, which are to examine the relationship between paraphrasing tool and academic achievement, because we use paraphrasing tool, referencing tool, and the translating tool to proceed artificial intelligence, which we now try to check them against the academic achievement. And all this later translated to our hypothesis. Methodology. Our study area is Federal Polytechnic here. And the reason being that, we are in the era of the pandemic. So, and the issue of restrict our research. We have access to our staff. We have access to to our students who are also on ground, because we don't want to deviate from the what is it called, palliative regulatory or regulations on ground. And the research design that we have used a survey research design, and our population of study, we are our final year students and our academic staff. And they are totaling 2,561 respectively. And from this, we came up with a sample of 364. Though you may say 364 is small, but we base our sample here on the Mugenda assertions, which says any sample above 10% is representative enough. So the sampling technique that we are using is simple random techniques, and the instrument that we have used to gather our information, our data that we later process was a questionnaire. And we try to test the psychometric property of this our questionnaire through Krubash alpha and the component factor analysis. And then we use a multiple linear regression, and then we have our model specifications here. From the data gathered and analyzed, as you can see our descriptive statistics here, we have a 364 number, respondents that we try to dash out our questionnaire to. Hello? Hello, can you hear me?
Please carry on, we can hear you.
Please go on. Okay. Sorry for the interruption. But you need to be rounding up.
And our correlation coefficient, our correlation coefficient here, as you can see, they are all valid. And our model summary, our R square is a 0.718, which shows that our independent variable have high level of influence on our dependent variable. So from the analysis, the study concluded as follows. Now, based on our findings, we concluded that artificial intelligence, which we proceed using a paraphrasing tool, referencing tool, and translating tools, have a high influence on academic achievement. And from there, the study recommends as follows: that higher institutions should factor in the use of the artificial intelligence tool relating to academic activities into their curriculum, since MBT make provision for inclusion of the local content into the curriculum. I use MBT because, we use a polytechnic as our own case study. And again, our institutions should provide training to academic staff on academic-related artificial intelligence tool. And again, our institutions should try as much as possible to give effort towards encouraging students and staff to make use of the academic intelligence tool by acknowledging and rewarding all outputs whose processes were based on artificial intelligence. Thank you very much.
All right, thank you very much. We are grateful for your presentation. Do we have any question for Dr. Ogunsanwo? Okay. If there is no question, Dr. Ogunsanwo, we are grateful for your presentation, and we thank you very sincerely for being part of us in Faculty of Science International Conference 2020. We are very, very grateful. Now, I want to call on Dr. Keshiro to do his presentation. Dr. Ogunsanwo, please, can you drop your screen? Can you stop on sharing so that Dr. Keshiro can share his screen? Yes, thank you very much. Okay. We are grateful. Thank you. God bless you. Yeah. Yes, Dr. Keshiro, please, can you share your screen and take your presentation? 7 minutes. If you are not making presentation, please mute your mic so that you are not interrupting our presentation. Thank you.
Hello, can you hear me, sir?
Yes, please go on. 7 minutes, please.
Okay. Good afternoon, everyone. I am Dr. Keshiro. I am presenting my research titled The Fabrication and Theoretical Simulation of Dye-Synthesized Solar Cells using onion skin, turmeric, and golden apple as organic sensitizers. Energy, as we all know, that the consumption of energy has increased due to population increase, economic growth, and industrial revolution in the past few decades. And this has led to a shortage in the fossil fuel, as reported. Now, to deal with this shortage in fossil fuel, alternative sources of energy has been requested. And among this, in the search for alternative sources, we were able to delve into dye-synthesized solar cells. Now, dye-synthesized solar cells are solar cells that are fabricated from dyes. When I mean dyes extracted from natural plants around us. Now, in the past decade, presently as of 2019, the laboratory efficiency by synthesized solar cells is at approximately 12%. Though this is small, but it's also encouraging for the future. Now, dye-sensitized solar cells are composed of four major parts. We have the titanium dioxide, we have the dye synthesizer, which is the dye that was extracted from the plant, which enables the absorption of light. We also have the electrolyte, and we have the semiconductor or the counter-electrode interface, which facilitates the transfer of electrons to the electrodes. Now, this diagram shows the schematic structure of a dye-synthesized solar cell. Now, in extracting the dye, we were able to get plants from the neighboring market at Yanoba in Lagos, and we extracted these dyes using methanol and ethanol as our extracting solvent. The absorbance of each of these dyes were taken using the UV spectrophotometer. Also, we were able to carry out the phytochemical screening on these extracted dyes to test for which compounds were present in them. The simulation was carried out using the method of Spuriator of 2019, using the characteristics of the natural dye. And also, the fabrication of this dye was carried out using the method of Boyo et al. 2019. From our results, from figure 1 to figure 10, it shows the absorbance of each of the dyes. And we're able to see that these dyes were able to absorb light in the visible region of the electromagnetic spectrum, which is a good response, which tells us that these dyes can actually absorb and generate electricity. Now, from this, we're able also to go further and determine the photovoltaic parameters of these dyes under outdoor illumination. And from table 1, which shows the ethanol extract under outdoor illumination, the best efficiency was for onion skin, the skin of onion skin, which was at 3.340% compared to other dyes extracted using ethanol. Now, also from ethanol, the best efficiency was also obtained for onion skin at 2.72%. After doing the outdoor experimentation, we also went further to do the indoor illumination to determine the photovoltaic parameters. Now, during the indoor illumination, the light source was at constant intensity. And we found out that the best efficiency derived was for turmeric at 0.14% for ethanol extraction. And also for methanol extraction, the best efficiency was also derived for turmeric. Furthermore, the phytochemical screening, this table 5 shows the phytochemical screening for each of the dye samples. And it was realized that the major component that was present in these dye samples was the flavonoids. Also, the flavonoids aid in the absorption of light. So from the phytochemical screening, we can see that the flavonoid is actually more present in all the dye samples compared to other compounds. And these flavonoids aid in the absorption of light, also with anthocyanins. Sorry. This is the graph, the ivory graph for the dye samples that was obtained, which had been presented in the previous table. Now, this is a simulation curve. We went further to do the simulation of these dyes, and we found out that for the ethanol extraction, turmeric gave a better power conversion efficiency compared to other ethanol extracts. And for the methanol extract, we found out that the onion skin gave a better efficiency compared to other dye extracts. Now, the indoor performance for the metalonic dye extract described in table 4, it shows that the onion skin produces a better performance with an efficiency of 0.0170%. And also for the indoor experiment, we found out that turmeric and the golden apple produce better performance than the methanolic extract. In conclusion, from this present research, it can be concluded that dye-synthesized solar cells fabricated using turmeric and the other plants are synthesized are capable of converting solar energy into electrical energy. However, turmeric and onion skin showed more potential than golden apple as a source of green energy. Also, we also encourage that further research should be put into natural plants around us in order to see which dye plants can give a better efficiency, because this is the way forward now in research into solar cells. We are trying to reduce the dependence on silicon solar cells because they are quite expensive. Though this efficiency derived from these plants, from these dye samples, are low at the moment, but in the nearest future, we are hoping that the efficiency will be high enough for commercialization. Thank you very much.
All right, Dr. Keshiro, we are grateful for your coming to join us.
Dear participants.
Hello.
Please, it's time for chairman of technical sessions.
Yes, sir.
Please, we are about going for the plenary. The third
all right, sir. We just concluded
program today.
I want to give the vote of thanks to the presenters.
Our technical session and ask everybody to move to room 1.
Okay, sir. All right, everybody in physical science room 1, we are grateful for your coming to
Please,
be part of us in Faculty of Science International Conference.
The technical session continues by 1:50.
Please, let's move to room 1 immediately. Thank you very much. I appreciate all of you for your contributions. Thank you.
1 p.m. Nigerian time, West Africa. We are commencing the third program.
I just finished presenting. That's why I didn't reply your message.
Third lecture for our plenary. So we want all technical sessions to end and everybody moves to room 1.
I just finished presenting. That's why I didn't reply. I didn't respond to your message. It's fine. It was fine. You said they were rubbish. You said it you wanted to say.
We have Dr. Nayak.
7 minutes. I was given 7 minutes.
Okay. We have Dr. Onosaya too, the permanent secretary, Lagos State Ministry of Agriculture.
Have you cried anymore?
Please, let me just, so that we know that our speakers are in the, I've seen.
Why?
Good afternoon, sir. Okay, Dr. Onosaya come on live. So please just,
I know you have to.
Yes, sir. Just hold on for us.
Okay, thank you.
And then Dr. Pratip Nayak, are you there?
Please don't bother yourself.
Oh, yeah.
Hi, Professor Akintola.
It's good to see you.
I'm here.
Okay. So I think without much ado, we will commence this session, starting with, if you check our program, the first session will be a presentation by Dr. P.K. Nayak from the University of Waterloo, Canada. Incidentally, Dr. Pratip is my boss in another program, a $2.5 million research grant. I think the total is about $7.8 million grant. The person is an achiever, somebody whose citation, when it comes online, you will see that is the person who is very fit to lead this plenary session, and we are going to enjoy the slide. If the control room is ready, we can have the citation of Dr. Pratip.
Can I share my screen?
Dr. Pratip, you know you are a distinguished scholar. It would be good that people know your pedigree. So just hold on for a few minutes. Your profile will come online very shortly. Okay.
My going, then the promotion must offend the
Dr. Anjori, the chairman of Abstract Committee, will read the citation of Dr. Pratip Kumar Nayak.
So thank you, Chairman LOC. And that is our leader, Professor Shehu Akintola. I have the privilege and honor to read the citation of Professor, an Associate Professor, Dr. Pratip Kumar Nayak. He is an Associate Professor, as earlier mentioned, an Associate Director of Graduate Studies. He's also the Project Director, Vulnerability to Viability, B2B Global Partnership. Dr. Pratip's academic background is in political science, environmental studies, and international development. He does transdisciplinary work with an active interest in combining social and ecological perspectives. Pratip's research focuses on the understanding of complex human-environment connections, with particular attention to change its drivers, their influence, and possible ways to, can you please pull up? Governance, social ecological system reliance, well-being, environmental justice, and of course, political ecology. It teaches international development and environment. In the past, he has worked as a development professional in India on issues around community-based governance of land, water, and forests, focusing specifically at the interface of research, implementation, and public policy. He is a past Trudeau scholar, a Harvard Giorgio Ruffalo Fellow in Sustainability Science, a recipient of Canada's Governor General Academic Gold Medal, and of course, the SSHRC Banting Fellow. Associate Professor Pratip holds a PhD, that is doctorate degree in natural resources and environmental management, University of Manitoba in Canada, far back 2012, and of course, certificate in higher education teaching from the same University of Manitoba, Canada, far back 2011. And of course, finally, he has won several awards, honors, and distinctions, including the 2018-2021 lead author Intergovernmental Science Policy Platform of Biodiversity and Ecosystem Services of the United Nations, the 2017 going 2022 invited member Human Dimensions Working Group, Integrated Marine Biosphere Research,
And of course, finally, it was the 2010 Harvard Ruffalo Fellow in Sustainability Science, Harvard University. Thank you all and welcome on board the distinguished and erudite scholar, a principal investigator to the tune of a total funding of $3 million and several other grants. Thank you.
Hey, what a beautiful citation. That is to tell us by Dr. Jorin. Thank you very much for that erudition. We now have, it's my pleasure on behalf of the LOC here at the Lagos State University Control Room to hand over to the Pratik.
Can you see my screen? Can somebody confirm that you are able to see my screen?
We cannot hear you.
Yes, we can see you.
We can see your screen, but we can't hear you loud and clearly yet.
Wow.
But we can see your screen.
Can you hear me now?
Yes,
Professor,
go on.
Okay, can you hear me? Okay. Thank you very much, Professor Akintola and the organizing committee to invite me to this wonderful conference that's going on since yesterday and on very pertinent topics. It's a science conference that tries to combine both natural science and also elements of social science. What I'm going to speak today is more on the social science side, but many of my colleagues and myself have been working with a number of natural scientists, so we do a lot of interdisciplinary work. So you will see a bit of a glimpses of natural science and social science interdisciplinarity in my presentation, but I come across as a interdisciplinary social scientist, so most of my conversations with you today will be oriented in that direction. So the title of my presentation is, as you can see, of course, COVID-19, because that's the context where we are in. But at the same time, I'm going to bring in my work on multiple vulnerabilities and viabilities in small-scale fisheries systems, and which we understand as a combination of both the social and the ecological systems. And I will explain that, that in a bit. If you talk about COVID, and we have been experiencing COVID over almost close to a year now, 8 months or 9 months, COVID comes across as a significantly global force. So it has impacted people and systems around the world. Starting from the most developed country in the world to the least developed country in the world, and at the same time, it is a global force, but also it is a local force. People everywhere is experiencing this. What we are experiencing can be seen across multiple scales. So it has implications for time, because we are experiencing this over a long period of time. And even if we have a vaccine and we go forward, we're going to have the repercussions or impacts of COVID going into future time scales. So it is temporarily going to be very, very extensive. Especially, I have already talked about that it covers all geographies in the world. So what we are going to again experience is that the post-COVID impacts, especially in the fisheries sector that I will be talking about, is going to cross borders, cross geographical and spatial limits. And then the third one is COVID will have impact on the different mechanisms and functions of various systems, and particularly the fisheries system here. And I will explain some of that as I go into my details of my presentation. So I'm going to talk about how COVID is directly or indirectly going to impact the fisheries system, and within the fisheries system, particularly the small scale fisheries, which constitutes a significant part of the global fishery. If you look at the sheer numbers, 90% of all people working in the fisheries sector work in small scale fisheries, and more than 50% of the fish as food comes from small scale fisheries systems. So it is significant, and colleagues in another project from Memorial University call it too big to ignore, because it is simply large enough to be ignored because of the number of people and the kind of contribution it makes to the global and the local economies and livelihoods and food systems. But I'm also going to talk about small scale fisheries as a social ecological system. What is a social ecological system? In this particular slide, you might see a number of species and their habitats. And this comes from Eastern India, where part of my project is located. And if you take all of these species together, what it suggests is that it is signifying a rich ecological system. But the ecological systems do not exist in isolation. Ecological systems are always surrounded, or mostly surrounded, and interacted by humans. And in this particular slide, then you are looking at fishers, fisherwomen and fishermen are engaged in different kinds of activities around fisheries. So the ecosystem that I just showed you is not in isolation, but it exists in connection with humans. If we combine these two slides, then it gives us a complex social ecological system, whereby we say the social system is nested in the ecosystem, and the ecosystem is nested in the social system. So these are not two systems. These are they can be combined to form an integrated, coupled, and interdependent and co-evolutionary system. And there they thrive, or they maintain themselves through multiple relationships, multiple interactions, and numerous connections between these two. So we write it as social-ecological system. And the slides that I showed you now signify that how complex social ecological systems exist, whereby they combine human systems and the ecosystems as subsystems. And I would like to argue that the small-scale fisheries, or the fisheries system, is a complex social ecological system. So let's get into more details. So what the systems are becoming, and more so because of new drivers like COVID-19 and other kinds of drivers from the policy, from the market, and the and the natural and anthropogenic pressures. These systems are becoming vulnerable. So the fisheries system, the small-scale fisheries system, has become vulnerable. And vulnerability can be understood in a couple of ways, and I would like to reflect in three ways that systems can become vulnerable. The first is the capacity to bounce back, which is known as resilience in the resilience science, whereby when something happens to a system, the system has the capacity to bounce back. A forest fire happens, and then the forest grows back. Eutrophication happens, and then the system has a way to recover. So these are in natural systems, these are called resilience, and whereby the system can bounce back. So in terms of how these systems get vulnerable, we can always say that systems get vulnerable when their level of resilience is reduced. The second element that can cause vulnerability is by looking at various kinds of resources. Of course, as humans, we need an income to buy our food. We need a natural system to sustain. So all of these human, physical, natural, social, and financial capitals or resources are something that can determine whether a system is, or a a particular individual is viable or vulnerable. The third element is, of course, it's something that